शुक्ला की आवाज अभी भी नहीं आ रही। हम्म। हम्म। हाय अजय, यार
Hi,
inaudible.
Adi. Actually,
हाँ, now we can hear you. Hmm. Yeah, seems like we're live. Uh, can you just like make it full screen, the Chrome tab you're presenting, Akhil? Akhil, I think you are inaudible in the stream. Ajay and yeah, your voice is not there. Try check the OBS inputs. Yeah, just waiting for the moment you are speaking. No, I don't think you are audible in the stream. So, in the OBS, like the desktop and aux inputs, the level for the two, they are changing or they are just still. Mm. They just try to speak continuously. Yeah, no problem. You can try joining from the mobile, I guess. So then the audio will be received on the computer and it will be recorded. Hmm. Yeah.
Hello.
Yeah, just try and speak something. Still echoing, guys. or is it the live? Yeah, but you are not in a, you are inaudible in this chat room. We are we are unable to figure out the audio settings for Rakesh. Like he's audible in some place and inaudible in other, and vice versa. Yeah, you are audible in whereby now. Yeah, yeah. Yeah, it's visible to me. Let me just stop my my. So, can you try hovering over the this Windows setting mic icon, the notification tray? Windows mic option. Yeah, this one. Used by Google Chrome, but not. Like, can you open the mic settings in the Windows if it's capturing the audio or not? And maybe you can open up settings and check for the this microphone settings. Mm, microphone, microphone setting. Manage device, manage voice, sound settings, volume or audio, microphone array. Volume. Can you try increase this volume? This is can you open the OBS? Don't, I don't think you are audible. Mm. Look, OBS is not recording, right? So can you like tap on this OBS microphone setting right after the speaker icon? Yeah. So it's log volume properties. Generally used device. Try select.
Hello. Yes, yes. I think it's
Yeah,
working now.
yeah. Okay, okay.
Can you check on the stream as well?
So, okay. Can you just try continuously speaking so that I
Okay,
can
okay.
get the feedback?
So we have tried fixing the microphone issue, and I think it is fixed, hopefully. And it is checking on the live. So it will be great if I am audible in the live stream so that we can start from today. And we are going live after a year around, I guess, for something to discussion, for some discussion, and we'll be
So,
continuing this, trying to continue this.
so yeah, you are audible. Can you just like fire up the mic to 100? Like
Okay,
it's
okay, okay.
barely
I have
you're
I
barely
have
audible.
fired it up.
Okay.
Okay.
Uh,
Uh, Hi Ajay, hi Aditya, and I think we are live and we are good to start, right?
So I think you have to speak a little louder because you're still.
Okay, okay, no problem. I'll try speaking louder, and
Yeah.
hope that will fix our issue, and we can start after that. Okay.
Okay.
Okay, so
So I think you can stop the stream and restart it, and we are good to go.
let it go.
Okay, no problem. So let me share my screen then.
Okay.
So hi Ajay, hi Akhil, and hi audiences. So today we are going to start a new series maybe, and in this call we'll be discussing some white papers, maybe by Google or Microsoft, Amazon, or any tech giant,
Mhm.
and maybe some tech blogs also. So today we are starting with this white paper for Alloy DB,
Okay.
and we will try to touch few points. Basically, we'll try to understand how we can read a newspaper white paper, and how one should read it, and how one should get the correct grasp of the white paper and the whatever it says. So we'll try to figure this out together. So yeah, maybe let's start.
Okay. So Ajay, I think you have gone through some of this data or document, or we are starting from scratch.
Yeah, hi Akhil, hi Adi. So, during the time to look into this, so I hope we'll start it afresh,
Okay, okay. So
and then I
yeah,
can light up few
same
points
with
on it.
me, Ajay. I like tried reading it once only. I didn't get enough time
Mhm.
to research on it. So since we just discussed in the evening for this, so I think today's video will be highly driven by Aditya's insights and his, you know, expertise in the DB databases and system design concepts. And I think we'll be mostly asking questions to Adi today, and we'll be googling it, chat GPTing it. So
Yeah,
and we are starting a
definitely.
new series called NOOB Learns. So we are learning how to do a system design from today, right? So I think
So yeah, I'll try to share how I actually read that already, like in today already, and day before today also, like the first when I interacted with this white paper. So what I did was I just scanned through the everything, and whatever the terms or any jargons that are there in the document that I didn't understood, or I think I need to Google it. So at the time, I just Googled it and understood the concept. And from there, I have started a single node, and that it led to some another node, and that's how I gather all information. And at then, the document is very much like it's already what the outline, the highlights of the document is very fine. It's correctly written, so it itself concludes at the end and tries to engage the reader itself. So we'll just do it.
okay,
So Alloy DB, which is just a Postgres blend. So with this title only, we can understand that it's it is some service which is forked using this open source Postgres SQL, right? And so let's just quickly read it. We basically will try to scan it up and figure out what the paragraph says, right? Maybe we can do this one by one, like the one
sure.
part. Akhil, you can try and you can speak of whatever you got from this paragraph, and we can do
Mhm.
like that.
Okay. So you are getting you will be start, and then I'll go to next paragraph, and then Ajay will do the next, right?
Yeah. Okay.
Okay.
So we'll just try to read it in our own mind, and after that we'll summarize.
Okay. Okay.
So yeah. So by the time I am reading, you two also can read, and later we
Okay.
can discuss it.
Okay. Okay. I think you can read out loud so that our video does not get stale. So, or I can read
Okay.
aloud so that you can think.
Yeah, yeah, that's better, I guess. Like we can, other person can read, and the person who is summarizing will be
Okay,
like
okay. You can think
collecting
of it
thoughts.
and I try reading it. Okay.
Yeah.
So yeah, so the first point is about triggering. What triggers Google to make this? So Google Cloud is taking another step to further round out its database portfolio, taking a route that is similar to other cloud providers. It has chosen a flexible target PostgreSQL to develop a new API compatible database with enhanced functionality. The new release AlloyDB for PostgreSQL takes the PostgreSQL API and then extends it under the hood with Google technologies to deliver a database that is not only faster and more scalable than the vanilla open source version available with Cloud SQL. Clouds, Google Cloud's existing PostgreSQL service, but extends PostgreSQL into new territory with analytics and in-database machine learning. So, what is the gap that AlloyDB fills within the Google Cloud database portfolio, and how does it stack up against other cloud PostgreSQL derivatives? And with other hybrid transaction analytic cloud database emerging, how does AlloyDB differentiates?
Yeah. So this trigger paragraph is mostly, I guess, it's driving that like why what is they are like put on up as a service because and it also states like the existing Postgres, this Postgres DB for that they have already a service available. So like what's the purpose of this new service Alloy DB? And later we like they says that this helps in the analytics and in DB ML part. So and yeah, so mostly that and the hybrid transaction and analytical part of the database.
Okay.
Ajay, do you have like any other understanding apart from whatever I said, or Akhil maybe you can add up.
No, just straightforward. So nothing to add from my side.
Hmm.
Okay. I got a big paragraph. So uh, LRDB is aptly named as the principal alloy is common in two metals, so forge a new material unique properties. In this case, LRDB takes a possible element which makes it normal bring to the place of in this Google photo and the story number analysis the result is the highest benchmark LRDB optimal the standard possibility of modern forex. While leveraging gold is produced to ML and proud of analytics and gold Okay, so talking about the first paragraph, first it is explaining that why LRDB is aptly named. So we already know that alloy means combining two metals, right? So
Right.
so Google is combining their existing database with the open source database, which is PostgreSQL and which is being widely used. So, which makes its compatible platform appealing to the growing base of PostgreSQL developers. So, and Google has enabled AlloyDB with AI/ML analytics layers, and they have substituted core Google technologies at the storage. Like I have read somewhere about Spanner and BigQuery of Google, so they have associated
Hmm.
in the AlloyDB it. And what it does is to LRDB is that it lets PostgreSQL run on asteroids like it makes it 4x faster, and since it's leveraging Google distributed storage, which is like highly optimized, and we have heard that it is very like great designs. So that's about Google distributed storage, and they have also enabled machine learning capabilities in this with Vertex AI of Google, I think, and Google Star. Sorry. So Google's
Yeah.
targeting LRDB should sound familiar as a destination from traditional OLTP databases to cloud native platforms. So OLTP
So
databases means online transactional processes databases like MySQL. Uh, Adi, your screen is flickering sometimes. Yes.
yeah, I'm just googling it
Okay. Okay.
the exact
Okay. So
what this
OLTP means,
OATP really
yeah.
means.
So I have read that OLTP is online transactional processing. So can anyone tell me more about OLTP databases if anyone of you knows more about this? So I think like I have read that it is mostly MySQL databases and similar to that. Uh, and can you like scroll down a little bit?
Ajay,
Move it to
you there?
OLTP.
Yeah.
Yeah. Okay.
Uh,
No problem. So, like, on the high level, like Akhil said, I have also went through the very definitions of this. So, by the definition, in just high level, I guess the OLTP it includes the transactions. So, transactions basically points to the relational databases which supports asset transactions. So, basically, the MySQL databases like MySQL and this whichever relational databases who supports transactions. And on the other hand, OLTP basically the data volume is very huge, and we are processing that huge data to get some insights, like to draw some conclusions with that data. So that is a very like high level difference of the OLTP and OLAP databases. I can we can assume. So let's get back to this white paper. So in the later part, like it states that they have majorly two competitors. So that one is Amazon's
Aurora
again
Postgres. Yeah.
yes, that is Aurora, and then Oracle's new MySQL HeatWave. So that is not related to Postgres itself, because Oracle has like MySQL is developed by Oracle only. So the HeatWave is some extension, maybe a service over MySQL
Yeah, so they are moving their databases to cloud. So they will be providing services to the companies, and in place of
basically.
companies going in-house infrastructure, they will be using their services as Amazon
Right.
does for most of its services. So also in the next paragraph, we are not surprised that Google choose to introduce an extended Postgres product, not only because AWS and Azure, since AWS and Azure are top cloud providers. So Google is also doing that to not, like behind in the business, left
Right.
behind in the business. So not only because AWS and Azure have done the same, but also because of the open-ended nature of the PostgreSQL open source project that encourages. Yeah. So since PostgreSQL is open source, as we know, that it encourages people to extend it to mold it according to the need. So they are adding more functionality to this, and LRDB will take its place as transaction processing platform with inline operation analytics. The optionality will complement, not replace, BigQuery or Cloud Data Proc. The BigQuery or Cloud Data Proc are Google products. And sorry, Adi, your screen is flickering in, like, it's the screen
I
share
think
is
there's some
going off and on.
data. I think there's some network bandwidth issue.
Okay,
Is it?
okay.
Is it any better now?
Yeah, yeah, it is better now. So
Okay.
the BigQuery or Cloud Data Proc, which are designed for greater scale and more complex analytical workloads. You can compare BigQuery with Snowflake, if you know about Snowflake. Nonetheless, leveraging a common storage engine, we would like to see greater blending of these services. At the end of the day, we believe that use case and programming environments are simply front ends that can leverage common building blocks to appeal different target audience and use cases. So at the last line, they have written that ultimately the use case of any DB, any complex simple DB is to just so front end, the basic building blocks to appeal different targets of audiences and use cases in a much better way or efficient way. So that's about that. What was the I what was
So can you tell us more about the Snowflake and the BigQuery?
so
On a high level, like when I interacted with GCP, the Google Cloud platform, when we were in the our 4 years. So basically, there are like what
data
trillions and
warehouses?
trillions. We are able to like query on the trillions and trillions of rows in seconds with the help of distributed systems they have set up in the last decade or so. And so, can you add more about the snowflakes that you know or you have interacted?
Yeah, so I know that Snowflake is a data warehouse, since so the BigQuery is to the data warehouse. So what is data warehouse is basically that it has a large number of databases. So we can query in n number of databases and n number of schemas. And Snowflake is, I think, leading data warehouse company. So that's about it. And let's search what is a data warehouse. So we'll get a bookish definition of this as well.
Mhm.
Data warehouse is a digital storage system that collects and organizes large amount of data from multiple sources to support business intelligence. So suppose you are a big organization like Swiggy, Zomato, or any other Indian startups, and you have a lot of databases. So suppose you have a database of orders. So you have database of riders, you have database of clients, you have database of food. So you will be storing those data in different, I think, databases as per your need, but you need a centralized system from where you can query those data so that you can get insights of for your data. You can build models on that data. You can analyze those data for different kinds of business functionalities like detecting frauds and getting like what is the average stat time for your business, etc. So I think for that purpose data warehouses are used, and these companies like Snowflake and and products like Snowflake and BigQuery are the medium for that only. Yeah.
So by the very definition, like it's very clear that a database is likely to be very small storage as compared to the data warehouse,
Right.
because warehouse, as its name suggests, holds a large volume of data, maybe like TBs or TBs of petabytes of data, maybe. And wherever large data exists, there exists analytical part to it, attached to it. So basically, like in my company as well, the people who are like in the data processing, data scientists team, so they are processing these, like they are querying over these warehouses and like figuring out the
Okay. I think we can move to
like,
the paper now.
yeah, sure. Now alloy DB again.
Yeah. So Ajay, can you take this up? LRDB is a fitting name. We can grow. We can go paragraph by paragraph, small paragraph to small paragraph. So
Yeah.
yeah.
Okay, so an alloy is an example, classic example of 1 plus 1 equals 3 procedure the Google is generating a new material. So what actually this para actually says is key, as the name suggests, the alloy, the main logic of calling it an alloy is basically combining two properties of different elements or different sources and then creating a third one, which will basically be a combination of the first two, right? So basically, this new LRDB, what the main
Is supposed to
target
say.
of sorry, yeah. So this is a basically API compatibility integrated with PostgreSQL. That is main basically logic of building this LRDB, right? It combines, so it basically combines the source core technologies and also basically integrate the PostgreSQL with API, sorry, API command. Wait a minute, let me go through that first.
No problem.
Disaggregated current storage record architecture that then the query spanner and many other Google services. So, what it said is basically key. With the PostgreSQL, they are combining various Google core technologies that are BigQuery, getting black screen actually. Yeah. That are BigQuery, spanners, and other Google services like Google ML technologies and all those things, which basically helps allow DB to work 4 times more faster and with the transaction, basically the OLTP type, and also it increases the workload, analytics workload up to 100 times with the compared to the current ones that are working currently. And as we all note, as an API compatible implementation of API is hardly unique and cloud-based services, but key is a use case of its target high throughput. So yeah, this is the main uh, benefit of this will be the main benefit of using LOIDB, that it will give us the high throughput transaction processing with inline operation analytics in it. So yeah, as the name suggests, it actually combines the Google's core technologies with the PostgreSQL and gives us a very faster transaction outputs, and the analytical workloads also gets increased using Google's current technologies. Yeah, so what I understood from this paragraph.
Great.
Yeah, so mostly like it's powers 4x the Postgres transactions and 100x the analytical workloads. And like I have underlined two terms: the high throughput transaction and inline operational analytics. So, like can anyone explain the high throughput system?
What you are high throughput transactions?
High throughput system.
Okay, so
What I can assume from this is कि basically the daily day-to-day transactions that generally PostgreSQL, whenever we use PostgreSQL, we are expecting basically not only for PostgreSQL, it is for relational databases. So when a very high amount of transactions come to the PostgreSQL to the relational database system, it might get the process a bit slower. So what AlloyDB will do is doing is it is basically uh, um, with the help of their technology, they are increasing they are maintaining this high throughput processing. The basically the number of transaction or the handling of those will be very much what we can say
Yeah,
powerful
optimized.
compared to the optimized is a better word for this. And inline operational analytics basically what we can say um, analytical data, is it targeting to analytical data, or I'm not sure about the second one, but yeah, the high throughput I can say about this. Let me search that also.
I guess like it's that only. Like we can query high volume of data for this analytical purpose, and by the meaning of inline, I think the queries can be run in instead of like instead of an async process, like where we have to wait for the processing of the analytical query. Instead of that, like we can query simply like how we used to fire it over a normal database table. So maybe that, like I'm just trying to grasp this on a high level. Okay, no problem. So let's move further. At first glance, AlloyDB has parallels with BigQuery. They're both separate compute storage, making them elastic. Both use Google distributed storage. Both are fully managed that can integrate, and both performs analytics and in-database ML. But that's not far as similarities lie. AlloyDB is designed as hybrid, combining high throughput transaction processing with analytics. Spoiler alert. We think two could be paired together as a blended service, but we are getting ahead of ourselves. So here, like it itself contradicts with the services that already exist in the Google Cloud system. So that's BigQuery and the spanner that you have already, like we have already discussed, right? Again, and Ajay. So it says like there are some parallels with this. The AlloyDB has some parallels with the BigQuery and the other services that are already present with the GCP, but it's not just that. The power of this LIDB is more than that, and like because of its like API API enabled part, so it's more capable in like the different use case computer, I guess. LIDB LIDB storage uses ML optimize it. Base data is processed storage, and there are several levels of memory and flash for hotter data. It also adopts a common practice among cloud-native database services for multiple replicas. So here, like it's saying, basically whatever data is not just stored into the disks, they are not directly dumped into the disks. For like the data that needs to be readily available to the user. Those data are distributed among different hot data storage services, like in the memory itself or in the flash, like the SSDs or some from where we can the read is from where we can quickly read the data. And also like the read, so here we got this word read replicas. So what, let's try to highlight this part. So read replicas is basically, let's assume there's a distributed system where we have 5 nodes of this database, this Alloy DB database. And so do you guys know about the this election leader and follower wala concept on the multiple like distributed systems? Ajay
Uh,
and Akhil.
Aditya, can you speak going little behind? I think my speaker is humming. Can you try speaking it from backward little bit?
Okay, is it any better now?
Uh, no. Let me check. Can you speak again, and or you can write in the chat as well.
Yeah, okay. No problem. Just like signal me whenever gets any better. So what I'm trying to do is I have highlighted this read replicas one time, and I'm trying to break it down with the help of you, Ajay and Akhil. So we'll try to look into what read replicas are and how they work. So is it any better now, Akhil?
No,
The
no, no.
audio?
It's not better for me, Ajay. I think you will be able to hear him clearly. There is a speaker issue in my laptop.
It's okay. So yeah, I'm able to hear it. Can you please repeat your question if you're asking something, Aditya?
Yeah, so Ajay, I like highlighted this word read replicas. So I'm just trying to like discuss what read replicas are, and with that term, there's one another node that I have drawn. So leader and follower concept, like the concept of leader and follower with respect to distributed systems, maybe server or databases. So if
So
you have any, like, you
reader and
can,
yeah,
yeah, leader and follower.
yeah, yeah. So reader and follower basically implies to master slave concepts in the distributed system. So basically, master slave concept, what it aggregates this key, whatever master does. In case of the failure of master, the slave does a similar thing. And the read replicas, what I understood from my uh, from the past experiences that I have done, read replicas basically we use those inside the relational databases. It is basically helps us in uh, maintaining the transactional what we can say transactional process in the system. So in case of uh, let's say if you have implemented transactional process in your relational database, and in case of any rollback, this replicas basically make sure ki whatever database, whatever changes that you did in your like in any one of your table, this read replicas make sure that your database gets rolled back to the original one. The replicas basically stores the copies of the original database, and this also is very similar to the one that you said, like said na, ki leader and follower structure. So here the master database. Hello, am I clear? Am I
Yes,
Yeah,
audible?
yes, you're
yeah,
audible.
absolutely, Ajay.
So yeah, here so basically the read replicas. The main database will be our master, and the replicas will be the follower or the slave for us. So in that fashion, what I understood from you. Anything you want to highlight other than this, Aditya, or if you want to correct me if I have some wrong understanding, and comment on
Uh, yeah, so I would like to add, like recently I'm following some system design articles and stuff relaid to it. So basically, like whatever you said about the master and slave architecture, it was correct. And about the read replicas and how leader is elected, what are the followers. So I'll try to like make that point clear. So let's assume there are like 5 database instances because we want our system available. So, and like the partitioning is done in a way that every okay, let's not get into the partition. Let's talk about the
Uh,
individual
just
database, and
uh,
we have five nodes of it.
hello.
Yeah.
Sorry to interrupt you, Aditya, but I'm also facing the same issue of like some humming is coming from your mic actually.
Okay. Let
I
me.
don't know if I mute myself, then let me check once.
Hello. Is it any better now? Hello.
No, actually, humming is coming from your voice only. Like basically, uh, same whatever you are saying, some like in humming fashion, the same things are coming back.
I have added this noise reduction. Is it any good? Hello. Hello. Hello.
Hello.
Yeah.
Yeah. It is a bit better now.
Okay. Okay. So where I was, okay, let's assume like there are five database nodes, and so we won't be writing our data to each node, right? There should be one write entry point, and everyone should else should be readable. Because if we try to yeah, okay, Akhil. So because if we try to write into multiple nodes, so they will be inconsistent. Like maybe Ajay will be updating the amount value 2000 and I'll be updating it to 2000. So there will be inconsistent data in the databases. So to resolve this, we'll be writing into only a single node, and that will be called as master, and every other node will be a follower. Basically, the data will be replayed into these what nodes based on the logs that are right. Basically, write ahead logs are saved in the master databases in case of Postgres or similar databases. And these write ahead logs are passed to these slaves, and the logs are replayed, and data is constructed in a way that it will be it's assumed to be consistent among all the nodes. And now the concept of this master slave, like what happens if a master dies? Basically, I have elected the leader is dead now. Like it's there's some resource utilization maximum. It got the CPU got fired up to 100%, and like the RAM is not available. So basically, the this database has died. Now, what will happen? So all the other followers will be a candidate, right? They will be eligible to like be a leader, and they will have their own login system, and everyone else will be follower. And so what happens, they vote, they like we just however the election is conducted on in our country, in the similar fashion the election is uh, yeah, hello, hi Akhil, am I audible?
Let me send Ajay my link as well.
Sorry.
Am I audible? I have sent Ajay my link. I think he wants
Okay,
to.
let's wait for him to join.
Actually,
And
I
by the
have to
time let me
send.
open Excalibur so that I can illustrate something.
Rejoin. I think I'll need headphones or earphones, Aditya. My speakers are, like really, really bad, sounding really bad. I can't hear you properly. I can
You
just catch
was
a
not
few words and I try building around that only.
okay. Okay, but is it any good now? Like I have enabled noise cancellation.
I actually I don't find captions in the whereby as well, so that I can read those if there are available.
Hmm, नहीं कह रहे.
No, there are no captions actually. I think
Hello. Okay, let me try and get
no, no problem. You
noise.
continue. Let me search for. Like we can do this today. Only like few paragraphs are remaining. Only we can wrap up this. We can wrap this fast.
Okay, no problem. Let's get back to the white paper. Where it is. So the read replicas, maybe you viewers and people can back this later. Since it's not, it's breaking a lot. Akin, maybe you continue the paragraph.
Uh, have you stopped speaking? Continue for the rest of Ajay. What? Continue for the rest of it, Ajay and Akhil, because my mic is not clear. Okay.
Okay, so let's deep dive. Let's start with low latency regional log storage for depend only write headlocks. This is the fast. This is the key to file threads and it's much faster than writing pages. And log processing service that asynchronously streams writes into primary and block storage replicas. Then for long-term storage, sharded regional block storage across three zones. Because the storage is separated from compute, write log processing can scale up and down with loads. There are multiple instances of log processors in each region. Okay, so okay, I guess Aditya is having some challenge in connecting with the audio. Okay, so what I understood from this is key basically it is explaining the process, the backend process of how this uh, implementation LRDB does. So it says that key it starts with low latency regional log storage for appending only if the write ahead logs are there, then only we are using. Then they are only using low latency regional records,
Okay.
right? Then a log processing service that asynchronously streams right into primary and block. I'm not sure about this one. Can you bring some light on this in the second line? Then a log processing service that asynchronously streams.
Okay, I think then a log processing service that asynchronously streams writes into primary and block storage replicas where update happen and then for long-term storage. Is it talking about the logs of the system or something else? There are log processing service that asynchronously streams.
I guess if it
Mm-hmm.
is streaming asynchronously and writes into the primary, it is logs actually. Systems log. The
Okay.
database is logs.
Streams writes into primary and block storage replicas whereby updates happen and then for long-term storage. Sharded regional block storage across three zones, and because storage is separated from compute, void log processing can scale up and down with load, and there are multiple instances of log processor in each region. I think we can Google it, or we can Google the whole paragraph, or put this into Chat GPT for, like better explanation. Let me put this into Google. You also try this, so you can just take screenshot of the, and throw it to Chat GPT.
Hmm.
You can try speaking, Aditya. I have connected an external speaker. Might be that the issue gets resolved. Are you speaking? Or because you are not audible at all.
Hello.
It is
Is it any
reversing.
better?
Can you speak again?
Yeah. Is it any good now? Hello.
Yeah. Yes, yes, it's better.
Is it still reverbing?
A little bit.
Okay.
Okay, okay. So I searched about what is log being referred here is that a log is a sequential record of all changes or modification made to the databases. So I think
Right.
they are dividing log to different categories. Uh, so it starts with low latency regional log storage for append only write ahead logs. So what is write ahead logs? Write ahead logs writes are first recorded in append only logs. This mechanism is highly efficient because writing logs is faster than writing full data pages to storage. And these
So
logs
basically, what they are trying to draw in this paragraph is that we discussed about write ahead logs, right? The WAL part. So
okay.
in case of regular Postgres node that we have spinned up, the val is present itself in that node only. But what they did is they have like decentralized it, or maybe like they have separated it out from the node and they have created an async process for that. So basically, whatever writes we are doing to the leader database, that val is like it's handled by a distributed system where it can like maybe we can assume that it's highly available and it writes in the real time, and later those vals are like replayed across all the follower nodes so that the data is made consistent over all the nodes basically.
Okay,
So the
Aditya, like
separation is, yeah.
if you can explain this with any real world, like data or example, that would be better. So that we can separate what is low latency regional log storage and then what is the primary and whatever it is written, what is that write ahead logs. So if you know about those,
Yeah, sure. Sure, sure. So let's take a basic example of banks because they make a good example for the transactional scenarios, right? So let's assume there's some bank, maybe Axis Bank, and we know that the use case user base is very high. So they have like millions of transactions, or maybe just not transactions, just updates that are needs to be like consistent across all the users, and they happens in like very large volume. So we cannot have a single database because if that fails, that will be single point of failure, and so your system will be shut and everything will be blocked, right? So in that case, we need to have like at least maybe three servers for single database. So let's assume that they have like set up three database for this for the user facing, like whatever transaction or whatever data they are storing. There's just three nodes for that. So three nodes are just replicas. Like whatever data is present in node A, it's there in the node B and C. But like we have already discussed that the data should be consistent across all nodes.
right?
So assume like I have to make a transaction. I have to debit $1,000 from my account, and so I'll be updating the database with minus 100 from my entry, right? Wherever the data sets. But if at the same time my account is debited with some EMI or something else, and that is overriding, like there's race condition. Maybe my ATM transaction has been made earlier, or that Nash has been made earlier. So the data will be inconsistent. How? Assume like I have like $2,000 balance. Yeah, sure, Arjun. No problem. So assume like I have $2,000 balance and I'm debiting it from my ATM like 1,000. So 2,000 minus 1,000, that's 1,000. So the end result should be 1,000 in my DB, right?
Okay.
And after at the same time, Nash is also like EMI is also getting debited. So that's minus 1,000. So end balance should be zero, right? But due to race condition, like maybe they are happening simultaneously, and any of them can be can happen first.
Okay.
So yeah, so at any given point of time, if that one transaction is not happened, so my balance is reflected as 1,000, which is wrong. It should be showing zero,
Right.
right? So so basically we are trying to avoid the inconsistent data. So for that, what we can do, we can just write to a single node. We can write to just node A, and every other can be follower, and we can just read from that. So the
Okay.
system is available, and like the load is distributed among all the DBs. So whatever the read queries are there, they are distributed, and the write is only done by a single node. And in yeah, so now what happens when the leader dies? Like, let's suppose the A services died, and there are only like n minus one services available. So all these n minus one services will be treated as a candidate, like they are able to be a leader. So election happens, and how election happens? Basically, each node they will send like each other node some health heartbeat, basically that I'm alive, maybe in period of 1 millisecond, 5 milliseconds, something like that. And this will be random. Why random? Because let's assume like one database has died, and all other databases send signals in 1 millisecond. So every database will say that I'm alive, so I can be elected. So every n minus one node will elect itself as a leader because I'm alive, right? So to make sure that this not happens, and they all does not get elected as a leader, what we assign random this heartbeat to each node. So let's suppose node B sends data this heartbeat every 2 seconds, and node C sends heartbeat every 5 seconds. So whichever heartbeat is received at the first, it will elect that node. So my heartbeat, node B's heartbeat is 2 milliseconds, and C is 5 milliseconds.
Okay.
Okay, let's suppose that node B's is 5 milliseconds and C's is 2. So C's heartbeat will receive first, and it will be elected. So assume that it in like very large number of
Oh,
collection of node.
you can present your screen. Like you can draw a few blocks. That will be better. So who is receiving
Mhm.
the heartbeat, and who is sending the heartbeat is a little bit confusing. So I think like we can use Excalibur to draw a few of the diagrams.
Okay, okay. Mhm. There is group.
Uh, does Control G works here or not?
Yeah, yeah, it works. Let's take an example. I think it can be shared, so let me share it with you so you can also, collaborate with me. Let's make it 5. And yeah, so that's D2, D3, and D5. Yeah. Now this one is my leader. So what
Okay.
is the what is the purpose of leader, or what is the properties of leader? Basically, we are updating this text update only happen in leader node.
Okay.
So that's the key part, how a leader is distinguished by its follower. And whatever other nodes are available, D2, D3, D4, D5, these are just read nodes. Like we can read data from these nodes, but we cannot update them. And what happens when we try to fire an update query? Basically, when we are making an UPI transaction, like our account is debited with some amount, so we are updating our account basically.
Mm-hmm.
So that update query is fired to this D1. It's sent to D1, and what happens inside D1 is that write ahead logs are configured. What are write ahead log? As its name suggests, whatever changes we are going to do with the database, we just take a log. Like before writing it to the database, we are keeping a log of that. Like we are just writing the steps that the query is going to do before actually
Okay.
executing the query. So that are write ahead logs.
Okay.
Now these write ahead, yeah. So we have generated write ahead log for this query. Whatever we are done, and this write ahead log is passed to D2, D3, D4, D5. So that these data are not stale; they are updated right after whatever transaction has been completed over D1 node, the update node, the leader node, right? Now, simultaneously, what happens? They send this. Sorry, D2, D3, D4, and again D3 will send it to everyone. So you got the idea, right? N into
Right.
N. So
End-to-end
every
relations.
every one node will send heartbeat to every other node, but these heartbeat should not be same, because we have already discussed, like they will then elect themselves as a leader, and every node will be leader, and so right will going to happen in every other node, and then like the system will be all chaos, the data will be inconsistent. So to avoid that, different heartbeats are set. Like D1 will send that I'm alive every 2 milliseconds. So let's say this is 2 milliseconds. How does this? And then this is 1 ms, and maybe
Yeah, this is I think more than enough 5 ms, and we can only write to 3, 4. We
yeah.
got the gist of this.
Yeah. So what happens? Like they will send signals. So we are. So this one was D1 was the leader, right? And now the D1 has died. So
Okay.
D1 has died. What does it indicates?
That
That
1 ms will
in
not be received.
yeah, the next 1 millisecond, it will say that leader has died. In next 1 millisecond, this will D1 and D2, D3, D5 all will say that leader has died, and we are now candidates. So election will happen. How election will happen? This D2 This one will say I'm alive after 2 milliseconds maybe. This one say I am alive maybe after 6 milliseconds. So what is the fastest among them?
2
So the two
milliseconds.
milliseconds, right? So maybe this was 2 milliseconds. So now it will say that since I have received this one very quick, so this should be the leader. And
Mm-hmm.
from D2's perspective, who will be the leader? Again, whoever is the smallest. Maybe like this one was 6, this one was 5. So again, this should be the leader according to D2 as well. And similarly for D3 as well, this should be the leader. So likewise, this one is elected as the next leader. So now whatever update, again, Akhil is debiting $10 from his account. So this update query will be head log will be first updated, and then actual data will be modified in the database. Actual query will be executed, and all other these nodes will be followers. And in the meantime, if this pins up again, like this get back to the life, it's alive
Okay.
now D1. So this will be follower. Why?
Okay.
Because only one leader can exist.
Okay.
So this is how, and like you will say, like how the leader and this uh, leader and follower is elected. So there's one algorithm called consensus algorithm. Con-
Consensus or consensus?
Consensus
Okay.
algorithm.
Does this election happens only when one of the leader dies, or it happens periodically?
So this is the whole scenario. And now, like in case of Alloy DB, what is happening? This val and query. So in let's let me draw some other DB. Yeah. So this is a DB. What is happening over here? Val is val is written first, then query executes. Right.
Okay.
The two processes are there. So in case this is a case for maybe Postgres. Post, maybe a regular Postgres node. Like you can spin this up in your local Linux
Hmm.
and create a val document. Whatever update queries or transactions you are doing, it will be you. It can be found over the val log, and then it will modify the data. But
Okay.
in case of RDB, what they have done is that select हो जाते हैं. In case of Alloy DB, this is also a Postgres extension or a post
Right.
forked
Right.
project, right? Yeah. So they have took out this part, like it's not present there, and they have created another service for that, an
Okay.
async service, and this will process all the val. So whatever query I'm firing, it will be first pointed here, and WL logs will be generated, and after that it will say that okay, AlloyDB like follow execute these update queries. So they have took out this part and they have scaled it infinitely. Basically, they have divided into three zones, like how they have shattered into three zones, and they are very fast. So they have splitted these two parts as a whole different services, and now this is very fast, and this is how they are basically making the
4x
transactions
faster.
4x fast.
So,
Yeah.
Aditya, these logs, they are stored in the DB itself, right? So first the logs are being stored, then the queries are being executed or something else.
No. Logs are not stored in the DB. Let me share my screen.
So those logs are temporary, or like where are the logs are being stored, or where we can find those logs?
Logs are basically, yeah. So in regular fashion, like if I have to like run PostgreSQL in my Linux, then it will be stored in the disks only,
Okay.
.log file.
Okay.
Yeah.
So
But in
in the
case of,
same.
yeah,
Okay. So okay, go ahead.
and in case of IDB, they have like they are saying that they are adding logs to basically disks first, and they are making it readily available
Okay.
by caching it on the, yeah,
Hot,
this
uh, hot
hotter data
and cold
storages.
storages. Right, right, right. Okay, okay,
Yeah,
okay. Got that, got that.
basically on the RAM and on the SSDs, the flash they are talking about.
Okay, okay.
This is how they are. Let me show you on live, like Postgres log, write ahead log. Can you see the Postgres folder? I'm
You can search,
struggling
you can search that.
there. Maybe before go, no go. Um, okay, I think I have downloaded it using this Docker, so that's why I don't have it. Mm, are you able to see my terminal screen?
Yes, yes. Spelling of Docker is wrong.
Yeah. What's command to check all the containers available?
Docker list, Docker ls, something like that. You want to list
Docker.
containers list?
Okay, containers are also not present. Then
Docker ps.
is there?
Docker ps
Yes.
hyphen a will do the, okay, so volume will be, so volume PostgreSQL.
Okay, Postgres is available in my system, but where does it? PSQL. This is the path user bin. So I'm going to user
Bin,
then bin. So
first one.
here writes Postgres.
Are those hidden?
It's loading.
Okay.
Okay. These are all just binaries. Where is the file path? What happened?
Are you
Postgres,
searching for any
Postgres
particular
service.
log or something else?
Equal also that we have to provide data folder name data. So whatever the encrypted or the compressed files the DB is producing, basically DB is writing either to the disk or the RAM and caching it to the basically writing to the disk and then caching it to RAM and some other storage level based upon the query type of query that you are doing. So
Okay.
the but whatever they are writing to the disk, they are very efficient. Basically, they are very small files and holds up large data.
Okay.
So these data directly wrote into those locations. Basically, in case of MySQL, that's slash data folder in the destination path. So likewise, in case of Postgres, the we have to provide write ahead log configuration, like where do so and these values are copied into other nodes to replay the exact update queries that we're doing. So that was the case, but unable to demonstrate it. Maybe I can took that up in the future
Okay.
white papers.
Okay. Okay. No problem.
Get it
So,
ready or like readily available. Make it readily available for the future sessions.
mhm.
Mm, yeah, so that was all about Alloy DB. Maybe like let's quickly get to the answer document. Basically, later, like I have already read this document. So in the later part, it just like how they have introduced the same thing, the ML and analytical parts in DB, and that are very fast as compared to the Postgres.
Okay.
So they have just
I have also searched few things in ChatGPT. So about, like summarizing the whole, document.
implemented out.
So
Yeah,
like
it's
it
just
created a basic, Alloy DB versus
out
Postgres
of
DB data table. So I think
Mhm.
that will be little beneficial. Let me present. Let me search it first. Okay. Let me present it to you.
Sure. PG service. PG restore. Host.
I think this is the document. So yeah, so this is the chat GPT result of sorry, this is Google Spanner versus that this is OLTP versus OLAMP. This is LODB versus PostgreSQL table. So these are the major differences, based on the features of LODB and PostgreSQL. Uh, Majorly, like there is a difference between performance and architecture and scalabilities.
Hmm.
So since a PostgreSQL, this is open source, you can run it on your system or any cloud machine. This scalability
Hmm.
depends on the manual configuration of the user. But since LRDB is offered by the Google, so they are offering as a service. So they already have a
Hmm.
huge infrastructure of Google Cloud. So you can say that these are infinitely scalable, since they already have
Hmm.
products like Spanner, which writes that it is infinitely scalable thing. So
Hmm.
and now talking about availability of LRDB versus PostgreSQL, since both same, since LRDB is a cloud based, so there are multiple zones where the LRDB will be hosted. So there will be, like if in case of failures, your hotspot will be moved from Mumbai to suppose Singapore or Japan and anything other places, but PostgreSQL will require manual setup of those.
Hmm.
And
Here, just we have discussed the master slave configuration
right,
so
right, right.
that they are followed.
Yeah. So one thing which arises, that what is the use case of LRDB? Okay, right.
Hmm.
So I can read that ideal for mixed transactional analytical workloads in the cloud, and for PostgreSQL best for diverse workloads but may need optimization for high scales. So Google has solved the high scalability problem and the throughput problem of the PostgreSQL with the
Yeah,
LRDB.
high transactional secrets basically.
Yeah. So they have added also analytical support, since machine learning and these things are rising on the go. So I think that is the need of our, and mostly I think this is for mainly business purpose.
Hmm. Right. Basically, they have enabled extension of Postgres and they are selling it
Right.
likewise.
Yeah. I
And
also read
also,
somewhere.
Mhm.
Yeah. Yeah. Go ahead.
Yeah. So I would like to highlight that the part that we have discussed in the Xcali draw about the how val is separated out from the actual execution, so that we can see in the architecture like the decoupled
Decoupled
storage
storage.
and compute.
Right. Right.
So the compute is basically writing the val, and storage is actually executing the query.
Okay, we can try reading AlloyDB architecture if we can understand, right? So if there is a high
Yeah.
level architecture of AlloyDB, that will give us a clearer picture of how things are interacting with each other. Because there are a lot of reading materials regarding this. It, AlloyDB for PostgreSQL. Let's open the first one. This is for from Google Cloud itself. So they are written analog application components already been using standard PostgreSQL protocols. That's application is processing. So where it,
Yeah, I think that it is.
this is the architecture, basic architecture, the diagram and example cluster scale to handle demanding workloads with inclusion of multiple load balancing read-only instances. Okay, your application SQL reads, SQL writes, read pool instances, read pools have primary instances, active nodes, standby, read-only nodes, read-only nodes. I think this is the picture which we were searching, right? Or but we were searching the insights of
Yeah,
the
very.
LRDB.
Hmm. Like where exactly the alloy DB sits. Like
Right,
we know
right,
it's like it's related to Postgres only, so it
right,
will
right, right,
be
right.
can be paralleled with that, but like how exactly? Mm,
I think we need to, like read paper about PostgreSQL as well to, and learn more about the LOIDB, because it's built on the
mm,
PostgreSQL and its APIs. So processes and memory architecture. I think this will be a test cricket type of learning for the database of PostgreSQL. We'll learn about different things.
Hmm.
The cloud goo. I,
Easter egg drops. So you can check out this Kailash Nath. Sorry, what's the city of this Zerodha?
Zero. The
Kailash.
CTO, I don't remember his name actually.
Kailash Nath. So you can check out his presentation on FOSS over the 1 million tables that they are storing in PostgreSQL.
I have
So that's very interesting.
Okay, I saw that video earlier, I guess. I think this is the wall
Yes.
files which we are discussing, that write ahead logs files. This wall writer inside the
Yes.
Postgres memory architecture and process architecture.
Yep.
There is a shared buffer, clock buffer, wall buffer. There are a lot of jargons in this.
Yeah. So this you can see the WAL files are written on the disk. On disk it's saying, right?
Right. So,
So we can like make since it's open source, we can make it point to the RAM, or like we can tweak the actual this Postgres equal to write it on the RAM and
mhm.
make it more like quick for quicker access. So same thing Google has done. It has like, moved into a whole another distributed system. So that a sync process will take care of this part, and it will not be on the actual data node. It is just separated. So that's a single point I can draw about this Alloy DB and Postgres. And apart from that, everything is same. Like since they have GCP and everything, so they can scale it and you can pay for that. But for the same here in the Postgres, you can have like n different virtual machines, and you can set up the like load balancing and everything, master slave architecture, and it will be same. But you have to do that manually. And in the GCP, you have to pay that.
Okay,
That's the thing.
right.
Mm,
Okay, I think we are done for the first.
yeah, maybe we are done for the Alloy DB white
Yeah,
paper.
I'll
So it was a
go.
nice.
Yeah, I'll go through the LOIDB paper once again with all the insights which
Uh,
I've got from you guys. So I think that will be
mhm.
a good read. So I think like we'll be reading some of the papers by ourselves again after going through all the video.
Yeah,
I know that these videos are very much cluttered, but it will go smooth with the time. We'll hope, and let's say
yeah,
that
that's
we'll
it.
be more
Maybe.
smarter each day after learning few of the things. Yeah.
Just to add to the conclusion, like three things. The one like how to read on basically how to read white papers. So three things. The first one is like we did. We are just scanned through the document, and we just try to grasp the high level thing, because the white papers these are only high level documents,
Right.
because the actual research paper you can find they are like 100 and 200, maybe 500 pages long, but these are just 5 to 7 pages long, so they are already high level. So what like how I and we Akhil and Ajay did is we just scanned through the document, we highlighted few points that we think we need to Google them, we understood those notes, and later we conclude the like draw our understanding of the document. So this is with these 3 points we can, I think we can understand any white paper like we just did.
And
So
one
that's
more,
that.
yeah, one
Yeah.
thing I would like to ask Aditya. So if anyone,
Mhm.
wants to learn about any white paper or any of these things, what would you suggest that they should be going through basics of some system design terms, or they should directly jump into this high level, like I think like this LRDB is a little bit high level paper for me, since there are a lot of jargons in it. So I needed, like to search a lot of the jargons. Most of it we were knowing with different names, Like, like OLTP,
Yeah,
we
yeah,
know that what is an OLTP, but we
right.
didn't know, what exactly it is. So what do you
Yeah, right,
suggest?
right. So for that, I think basically the white papers and discussions around we have only 5 minutes left.
No
So
problem,
white
go
papers
ahead.
and discussions around these what tech jargons. You have to be a little bit senior in your like you have to gain experience, right? You cannot expect a fresher to get into these discussions because they might not know the internals of databases or how the system itself works, right? So, I, for my suggestion would be first to gather information on the like we have touched so many jargons like distributed system, multiple nodes, this and that. So you have to know these things. These things might be very like uh, what we can say very small to us maybe like we have interacted with them so many times but that might not be the case for the freshers. So for freshers you first read these tech blogs like small chunks. What is a server, what is a distributed system, what is caching, what are different levels inside a system. Maybe you can follow Gaurav say Arpit Bhayani, what is
I
his name?
think
Arpit Bhayani.
Arpit Bhani, right? I think we'll
Yeah,
build something around this after we'll, like learn. I after we'll be capable of building things around this.
right.
I think
And
we can work
yeah,
on this, right?
definitely. And also, like most of the words or the terms we have used, you can find them in SRE part of the this tech domain. So also, I would suggest you all to like get a deeper insight on the how SRE or the how behind the system works. Basically, you are shipping your code. You have pushed your code to the production, but how it actually gets to the end user, so that matters. So for that, you have to maybe spend time with your DevOps team, spend time with a funny colleague, so that you can know how the deployment works, how different systems and services are used to like all together to form a product.
Right, right,
So
right.
that happens. Yeah, that's the thing. Basically, you have to read and have discussion, open discussion with your colleagues, maybe seniors and whatnot, people around you.
Okay. So thank you, Aditya, and
Yeah, and just one last thing. So the sources for these white papers. So how did I find it? So basically, Gaurav Sen posts a lot about the white papers that he reads. Similarly, Arvind Behani also posts white papers, and so you can follow or you can just blindly search white papers over LinkedIn search, and you get lots of posts. Enough for 1 year, maybe. Like you can spend time reading them.
okay, I'll attach in
So
the
that's
video
how,
description as well.
yeah. So that's how I encountered the white papers, and you can search for them as well. And later you can just make Google search for different new technologies and with white papers itself. So you will get the documents.
Okay,
On that note, I think we should conclude this meeting. What's there?
okay. Thanks, Adi.
Yeah. So thanks Akhil and Ajay. I hope you must be seeing after this an audience, and
Yeah.
we'll try to make it more concise in the later videos and more concise and organized.
Okay, okay. It's
Yeah,
ending. I'm stopping the stream. Thanks.
yeah,
Good night.